How does a 1920s era electric railroad running on 600 volts direct current through overhead trolley wire still survive in the 21st century when nearly every other interurban in America collapsed decades ago? Subscribe and stick around, because answering that question means following this crew through every switch throw, every bearing repack, and every freight move on America's last interurban, starting with this morning's power-up. At 7:30 in the morning, the Iowa Traction Railway hums to life, not with the push of a button, but through a ritual that has not changed since the days of flapper dresses and Model T cars. The engineer steps up into the steel cab of a Baldwin-Westinghouse steeple-cab locomotive, hands blackened from a morning spent checking oil-soaked waste in each journal bearing. There is no computer screen, no digital readout, just an analog amp gauge, a hand-cranked throttle, and a checklist scribbled on a clipboard. The first move is tactile. A gloved hand grips the trolley pole, guiding its spring-loaded wheel up to the wire overhead. The pole must be dragged, not pushed, so the contact shoe stays pressed to the copper wire as it sags in the morning chill. A faint click signals the connection. 600 volts of direct current flow from the substation through that slender pole into motors built before the Great Depression. The engineer watches the amp gauge needle sweep upward, feeling the slight vibration as current surges into the windings. Next comes the brake pipe test. The air compressor kicks in with a hiss and a pop, charging the system that will hold back a string of loaded grain cars. The mechanic, often the same person as the engineer, logs the temperature of each bearing housing, a ritual born from decades of watching for hot boxes, the silent enemy of plain bearings. Here, maintenance means hands-on. Every month, the crew heats and repacks the bearing waste, cleaning out the old oil and tamping in new, just as their predecessors did in the 1920s. This is not nostalgia, it is necessity. The line stretches just 10.5 miles from Mason City to Clear Lake, its 600-volt direct current system perfectly matched to the stop-and-go pattern of local freight. 4 steeple-cab locomotives, each around 60 tons, are the entire active fleet. There is no backup diesel, no modern electronics to override the operator's senses. Every move, every sound, every scent of hot oil or ozone is a cue in the choreography of survival. As the first train edges out of the yard, the question lingers. How does a railroad running on century-old technology still compete in a world obsessed with modernization? The answer is written in every tactile task, every bearing packed, every trolley pole dragged along the wire. Subscribe and stay with us as we follow this crew through a day where the past is not just preserved, it is the engine of resilience. On July 4th, 1897, electric cars rolled out from Mason City toward Clear Lake, carrying holiday crowds and marking the start of a new era in Iowa transportation. The Mason City and Clear Lake Railway was born in the thick of the interurban boom, a time when electric lines promised to knit together small towns and cities with fast, frequent service. At its peak, the line moved both people and freight, shuttling passengers to lakeside resorts and hauling grain, lumber, and dairy between rural depots. The 10.5-mile route was short, but it was built to standard gauge and wired for 600-volt direct current, technology that even then was seen as forward-thinking for stop-and-go runs. But the optimism of the early 20th century did not last. By the 1920s, the automobile was everywhere, and paved highways began to siphon off both passengers and small shipments. The Great Depression hit hard, drying up capital and shrinking the flow of tourists and local travelers. For many interurbans, the costs of maintaining overhead wires and track, especially after ice storms or wind damage, outpaced shrinking revenues. Across the Midwest, electric lines folded, their copper wires sold for scrap, their rolling stock left to rust. The Mason City and Clear Lake faced the same pressures. Its original charter, granted in 1897, had a fixed term. When the franchise expired on August 30th, 1936, the board faced a stark choice: abandon the line or reinvent it. Unlike most of its peers, the company chose to pivot. Passenger service ended that summer, with a bus subsidiary picking up the remaining travel demand. The railroad itself refocused on freight, retooling its fleet and realigning its business around the needs of local industry, grain elevators, mills, and later chemical and construction materials. The line's short length, captive customer base, and modest infrastructure needs made this transition possible when longer, more exposed interurbans simply could not survive. Three forces doomed most of the interurban network: relentless weather that battered exposed wires, chronic underfunding that left little room for upgrades, and the steady march of cars and trucks that made rail seem obsolete. The Mason City and Clear Lake's decision to specialize, dropping passengers, doubling down on freight, and sticking with a compact, easily maintained route, set it on a path apart. This early pivot insulated the railroad from the worst shocks of mid-century decline and preserved the foundation for the electric operation that still runs today. In the next chapter, the technical logic behind this unlikely survival comes into focus, revealing why 1920s hardware in the right environment can still outlast the march of progress. Electricity gives Iowa traction a mechanical edge that no diesel or steam engine can match. The secret is in the series-wound direct current traction motor, a design that delivers maximum torque at zero speed. When the engineer cracks open the throttle, the locomotive's full pulling force is instantly available, making it possible to nudge a string of loaded grain cars out of the yard without a hint of wheel slip. There is no waiting for boiler pressure to build, no lag as a diesel engine spins up, just a direct surge of power, perfectly tuned for the stop-and-go rhythm of short-haul freight. This torque advantage is not just a relic of the past, it is the reason 600-volt direct current still rules these rails. The steeple-cab locomotives are simple by design. Each motor is built to be torn down and rebuilt with basic shop tools. Brushes, windings, and bearings can be replaced or repacked by hand using parts machined in-house or sourced from hardware suppliers. The control gear is mechanical, not digital. Contactors and resistors rather than circuit boards. When something fails, it can be fixed on a bench, not shipped off to a distant service center. This repairability means the railroad is not at the mercy of proprietary electronics or expensive components. Every part is accessible, every system understandable. The same principles that made electric traction the logical choice for interurbans a century ago, immediate torque, low speed efficiency, and mechanical clarity, still fit the job today. The result is a fleet that can outlast trends, regulations, and even the supply chains that built it. In the next section, the proof is in the shop, a maintenance ritual that keeps these old machines running year after year. Inside the Mason City shop, the daily choreography is as much discipline as it is tradition. The mechanic begins with a bearing ritual that has outlasted generations. Each journal cap is loosened, old oil waste is pulled by hand, and fresh, heated packing is tamped in. This is not just for show. Plain bearings, while simple, demand constant vigilance, and any lapse can mean a hot box and a sidelined locomotive. The temperature of each housing is checked with a handheld gauge, and every reading is logged. Over the years, this monthly repack cadence has kept the steeple cabs rolling, even as other railroads abandoned plain bearings for sealed, high-speed alternatives. Out in the yard, the operations manager works from a schedule that balances reliability with efficiency. Each locomotive is assigned moves based on the day's traffic, factoring in the distributed braking system that was retrofitted after a runaway grain car incident in the 1990s. On grades, this system divides the braking force across the train, reducing the risk of a single failure cascading into disaster. Every departure is timed to avoid overlapping with the interchange windows of the connecting Class 1 railroads, a necessity when your locomotives cannot leave home rails. Since Progressive Rail's acquisition in 2012, selective upgrades have targeted what matters most. 15% of the trolley wire has been replaced with corrosion-resistant supports, and the main siding at Clear Lake got new heavy rail. But the core remains untouched. No roller bearings, no digital controls. Here, survival is built from hands-on routines, careful scheduling, and a shop culture that treats every part as both artifact and asset. The result is a line where reliability is not a slogan, but a lived practice, proven every day by the crew's quiet precision. Federal rules, written in the early 1990s, changed the fate of Iowa traction in ways no one could have predicted. When the Federal Railroad Administration and the Association of American Railroads banned plain journal bearings from interchange service, the steeple-cab fleet was effectively locked to its own rails. No waiver was granted. The line's locomotives, with their oil-packed bearings, could no longer travel onto Class 1 networks, and outside power, diesel or otherwise, was kept at bay by the low-clearance wire and tight curves designed for electric operation. What looked like a regulatory death sentence instead became a protective moat. The railroad, now a closed system, faced no pressure to modernize its motive power or overhaul its mechanical practices. For the customers clustered along this 10.5-mile corridor, the consequence was concrete. Direct rail service to their facilities meant no transloading, no drayage to distant interchanges, and a logistics bill trimmed by 10 to 15% each year. Progressive Rail's own analysis puts the annual savings for local shippers at nearly $800,000, a margin that keeps grain, chemicals, and construction materials flowing along the wire. The operations manager puts it plainly: as long as the rules keep the old electrics at home, the line's economics stay insulated from the volatility and capital churn that drive most short lines to diesel. Here, the regulatory wall is not a barrier to progress, but the very thing that lets a 1920s electric railroad thrive in a world built for something else. In an era obsessed with upgrades, Iowa traction proves that survival can mean staying precisely aligned, mechanically, economically, and locally. Its century-old wire still hums because it fits its world, not outpaces it. Sometimes, the future belongs to what endures. For more stories like this, consider subscribing.